Hi everyone, my name is Sneha and I'm excited to present our work titled System D, Augmenting Decision Making via Interactive What-If Analysis. This is my summer internship project at Sigma along with Madelon, James and Cagatay and is in collaboration with Peter from UMass Amherst. The current view on interactive visual data analysis has primarily been shaped by John Tukey's emphasis on exploratory data analysis. For business users such as sales, marketing, operations managers, etc., the analysis process begins with feeding data sets such as customer behavior or product interaction data into multiple existing data analysis and visual exploration tools to better understand the data sets. Users typically perform exploratory data analysis via carrying out complex slicing and dicing operations or tabulating and visualizing the data in different ways to find patterns or qualitative hypotheses within the data. The design of data analysis systems in the past few decades has focused on providing affordances for visual exploratory data analysis. But is it enough for business users to achieve their goals? Consider some decision-leading business questions, such as how can I best use my $200,000 marketing budget across advertisement channels? Or which activities should I prioritize to increase my deal closing rate? Or how much do free trials help with acquiring customers? Such business questions cannot be answered purely using exploratory analysis systems. There are many challenges that are associated with answering such questions using current analysis process of only exploratory analysis. In order to answer decision leading questions, business users generate and refine validate hypotheses. The first challenge is the limitation of human working memory and cognitive overload, which make it difficult for users to effectively run multiple what-if analysis scenarios to generate and refine hypotheses. The second challenge is when there are multiple drivers affecting the goals of users, large number of interactive querying and data transformations are performed to consider numerous combinations of drivers in the data and their effects on the business goals. This doesn't scale well for generating the hypothesis and therefore for making decisions. Further, the increased sizes and complexities of business data, which are easily and cheaply available now via cloud computing, complicate the process even more. Lastly, business users may not find the reasoning over possible solutions to answers of decision leading questions easy because the solutions may misalign to their own intuitions. To overcome the challenges of the current analysis process, we take a step back to understand the purpose of business data analysis and learn what the BI systems should be optimizing for. We find that business users do not just perform exploratory analysis, but use them as a means to improve business decisions. The users typically come to make these decisions by understanding the relationship or functions between two sets of variables, the input variables or potential drivers and the output variables or business key performance indicators or KPIs. Examples of input drivers are investments on advertisement channels, customer interaction with product, etc. And examples of output KPIs, which is often just one variable, are profit, sales, churn rate, etc. And the goal of business users is to understand this relationship to effectively enable optimization of KPIs, such as maximizing profit, sales, return on investment, or minimizing churn rate, etc. Further, since business users are not necessarily data scientists or statisticians, business data analysis should allow users to be confident in their decisions by backing the decisions with data and domain knowledge, along with common sense to enable improved decisions.
We propose 4 interactive functionalities that enable experimentation with the data using what-if analysis. These functionalities are driver importance analysis, sensitivity analysis, goal inversion or goal seeking analysis, and constraint analysis. We argue that all business intelligence tools should adopt all these functionalities to enable data-driven decision-making, which is the actual purpose of enterprise data analysis systems. To operationalize these functionalities, we develop System D, an interactive visual analysis system that helps augment business users with data-driven decision-making. Now, I will illustrate these 4 functionalities using the deal closing analysis business use case. Sales teams invest a lot of time and effort in selling products to prospective customers so that they can maximize closing their deals. To increase the deal closing rate, sales managers use prospects' activity history with products and their communication with the sales team. Here, we have a data set that describes the total counts of 20 activities that a prospective customer performed in the past 6 months to help close the deals and become customers. Each row is a prospective customer, and the columns are activities such as making calls, starting chats, attending meetings, opening marketing emails, etc. The data set also contains a true and false label of whether the prospect closed as a customer or not. The sales manager wants to analyze this prospect data and ask questions like what activities lead to converting more prospects and what is the ideal customer journey formula. To answer these questions, the sales manager tries to understand the relationship between the deal closing objective key performance indicator KPI and the prospect data. The sales manager cares about the deal closed KPI and selects it in the KPI view. She also deselects the textual drivers that don't contribute to the model prediction, such as account in the driver list view.
The first functionality is driver importance analysis. Using this functionality, the sales manager can implicitly learn relationships between prospect activities and the deal closed objective KPI, such as what are the top 3 drivers of the deal closing KPI. The driver importance bar chart informs her that the 3 important prospect activities that drive the deal closing KPI are prospects opening marketing emails, renewing their contracts, and making calls. While the activities that least affect the deal closing KPI are LinkedIn contact, trial signups, and replying to sales email. Once the sales manager is aware of what activities drive deal closing, she can use the second functionality of sensitivity analysis to dynamically evaluate the learned relationship of activities by making perturbations to the prospect activities and observing its effects on the deal closing KPI. For instance, she can know what will happen to the deal closing KPI if opening marketing emails were increased. If the percentage of marketing emails opened is increased by 100%, the company's deal closing rate raises by 4.05%. Or if the marketing emails sent is increased by 300%, the deal closing rate further raises by about 1.3%. Therefore, the company will benefit from encouraging activities that lead prospects to opening marketing emails instead of investing in sending more marketing emails. Just understanding the behavior of prospect activity isn't sufficient to guide the sales manager to take decisions on next steps. The third functionality of goal inversion or goal-seeking analysis enables the sales manager to interactively set deal closing rate target and know the driver values that will help her attain her goal. So for example, what can be done in terms of these prospect activities such that it will increase the deal closing rate by 75%? So optimizing the driver close to a 75% target gives 78.38% deal closing rate with high confidence and specifies the values of prospect activities that will enable this goal to be achieved. However, consider that the sales manager is under a budget and cannot invest in increasing all the activity values to optimal ones as proposed by goal inversion. Such constraints occur all the time in the real world businesses. System D provides the final functionality of constraint analysis that enables users to set constraints on one or more drivers, say increasing the opening marketing email between 5% to 10% and run goal inversion to provide optimal values that satisfy these constraints. On specifying these constraints and running constraint goal inversion, the sales manager finds that the maximal deal closing rate that can be achieved is about 46%, which is still an uplift of about 4% from the original deal closing rate and is feasible for the company. We performed a preliminary evaluation of System D with 3 business use cases to gather feedback on its interactive functionalities. The deal closing analysis use case, which we walked through, was to understand the ideal journey of prospects so they can close as customers. The second use case was customer retention analysis to answer questions such as how can the 6-month customer retention be increased? And lastly, we used the marketing mix modeling use case where the business users wanted to know how much to invest in different advertising channels to get the maximum return of investment. We evaluated the use case with 5 participants who were employees at Sigma and are a fair representation of business users since they perform data analysis to make decisions as part of their daily workflows. We recruited 1 participant from the sales and product teams each for the deal closing and customer retention analysis use case respectively, and 3 participants from the marketing team to participate in the marketing mix modeling analysis use case. We followed a simple protocol where we first learned about the business users' current analysis process, tools that they use, and their intent of using the systems like System D. Then we demoed the use case using the system, and users were asked to guide the demo. In the end, we provided them with usability questionnaire to get feedback on the system. Here are some quotes that the participants shared when demoing System D in the user study. The feedback provided by the usability questionnaire indicate that all business users saw very strong value in System D and express interest in integration of the functionalities in their choice of business intelligence tools. For example, they wanted to use Sigma formulas to create new features or columns that they could use in their what-if analysis. They found that the functionalities of System D were highly useful in quick testing and validation of their hypothesis of their KPI goals. However, the business users showed strong desire to focus on the UI and UX experience, further highlighting that they were not computer scientists, ML users, or statisticians, but wanted to leverage ML models and statistics to make their data-driven decisions nonetheless. Our preliminary findings confirm that helping business users to make data-driven decisions implicitly using models is a difficult problem which has many open challenges to be solved in the future. Business users interact with underlying models when they use the 4 functionalities. An important challenge is to develop methods that can measure and communicate the assumptions of the models to the users, especially with no statistics or ML background. Along with assumptions, model confidences must be conveyed to the users so that users do not undertrust or overtrust the model predictions. Undertrust can lead to users leaning more towards their intuition and less towards the historical data, while overtrust can lead to users blindly trusting the predictions of the models. Therefore, it is crucial for business users to have a sense of control on the business intelligence systems, even though they are built on automated methods. This opens doors for both modeling as well as system and user experience design problems. With even small changes to the model or data, the predictions or solutions may change the model behavior. For example, different models may yield different rankings or driver importances, or different solutions to optimization of the goal-seeking problems. Therefore, data analysis systems that are designed to augment decision-making need to take the robustness of the solution and multiplicity of the models into account. Third, it is important to understand how systems make predictions instead of just fostering trust via accuracy of the model so that business users can be confident in the system predictions. Therefore, there is a need for effort to make models interpretable rather than only have high accuracies. An exciting future direction is tracking users' what-if analysis and decision-making scenarios to allow for its reuse and better integration with the rest of the data analysis system. One solution is the development of a declarative specification language that can be integrated with SQL, for example, as many data analysis systems compile the intent of data analysis into SQL queries. Lastly, we are looking into conducting a formal, rigorous evaluation of System D to go beyond our preliminary results. We want to understand various business users' existing decision workflows compared to when they use System D. Some measures that could be useful are factors such as whether a decision can be made, the amount of time needed to make the decision, etc. Another useful next research would be to compare the functionalities of System D to the functionalities provided by other existing commercial tools such as Einstein Discovery and Power BI. The current view of data analysis systems is skewed towards exploratory data analysis. However, the purpose of enterprise data analysis in practice on the ground are neither pretty pictures nor exploratory insights, but are actually improved decisions. Through our proposed functionalities and its adoptions in BI systems such as System D, this current view can be shifted to the needs of data-driven decision-making for business users. Thank you.